Hello, everyone. My name is Nicholas Cadillo, Senior Application Engineer with Post-Process Technology. I'll be your guide today on our live solution experience tour here in our lab in Buffalo, New York. We'll be going over resin removal applications in our 40 and Demi resin removal machines. We'll also open it up to question and answer at the end of the session through the chat feature. And if we can't get to everyone's questions, feel free to sign up for one of our coffee chats with an application engineer. It's a great way to get one-on-one time and get all the info you might need on your particular application. We're also going to start by opening up with a polling question to get a little more information and insight on your current post-printing challenges. Alrighty. So the question is, what is your biggest post-printing challenge? Is it the length of time to finish parts? Is it damaging parts? Is it consistency of finished parts, throughput, or other? So we'll give you a few moments to answer the poll. And of course, we'll be addressing each of those pain points throughout the experience today. Alrighty. So, unanimously, it looks like length of time to finish parts is the largest challenge. So, we'll of course be addressing that today with our automated solution for resin removal. Once again, hi, I'm Nicholas Cadillo, Application Engineer with Post-Process Technologies. Right behind me is our 40. It's a member of our SDC Technology, which stands for Submerged Vortex Cavitation. Today we're running with our resin removal detergent, specifically formulated to attack all types of different resins, including Escalade, DLP, and clip technologies. Right here I actually have a sample part in the theme of our Unlock additive, a little key there with our logo. It's off of our Figure 4 printer from 3D Systems, utilizing our tough black resin. It's a pretty viscous resin, pretty goopy, what would be considered challenging to clean with traditional solvents like isopropyl alcohol, TPM, DPM. If you're running carbon, you're probably used to DPM, IPA, or Trel, which is a really expensive, overrated solvent. In any event, what I'll do today is I'll show you how we're going to process this key, or any other part for that matter, utilizing our tiered fixture here. You can see that it has 6 different tiers, and with the size of this Figure 4 platform, I can line up 3 on one tier, and as many as 6 depending on that Z height. Okay, so I have it on the platform. Of course, I could stack many more on here, but we'll give you guys an idea of how this works. But before I drop it, you can see that this particular fixture is adjustable with these screws, and so I can expand this out to accommodate any platform size up to 14 inches, or slightly smaller rather, to fit inside this 40. The Demi, which I'll show you in a few minutes, is larger, up to 18 inches in the envelope, and of course we have, I'll cover some other options as well. So I have this dropped in. Most of our cycle times are between 5 and 10 minutes. You can see I have this set up in automated right now, our automated software for a 10-minute cycle time. And I'll show you guys the nature of the SDC technology. So submerged, meaning it's submerged in the detergent. Vortex, so for the V, the vortex is that motion, the fluid motion that moves around the part, encompassing the entire geometry. And then cavitation, utilizing our ultrasonics to clean that part as well. So I'm going to go ahead and hit play. You probably hear the machine working. You can see that vortex motion start to work underneath the surface. We have jets that move the fluid in a circular pattern. You can probably hear that the vibrations of that ultrasonic energy as well. So we're going to let this go for the 10-minute cycle time. Meanwhile, I'm going to take you over to our Demi machine and show you how that works as well. Very similar. You'll actually be able to watch real time as I manipulate the software on the right-hand side of your screen there via the TeamViewer application. So I'm going to go ahead and get this set up briefly for resin removal mode. We're actually running PolyJet in there previously. So I'm going to select resin removal. Nice thing about these machines is that they're really versatile. So you can pair your detergent with whatever technology you're running, whether it be FDM, PolyJet, or in this case, for resin removal, SLA, ELP, or clip. Alrighty. So I'll give you a quick hardware overview. Very similar to the 40. On the right-hand side of our tank here, we have our ultrasonic transducer. It outputs in the Demi 4, which is a 220-volt system, up to 1,750 watts of energy, ultrasonic energy rather. The same vortex motion that you just saw in the 40. And it spills over into this sediment tank area on the left side where we have this first stage trap to catch any particulate, like if you were using a composite resin with solid particulate in it, or sometimes little pieces of the support structure break off. We're going to catch it in this trap before it reaches the pump. We also are monitoring the liquid level, the temperature. SLA parts, or most resin parts, if they're not high temperature applications, are really sensitive to high temps. So we do a great job of regulating that, making sure it doesn't go over 90 degrees Fahrenheit or so. A lot of people are used to traditional ultrasonic tanks, where ultrasonics do a great job for cleaning, but they introduce a level of heat that can be detrimental to your part. And so we've combined that with our automated technology to include some cooling functions as well, with fans, with high CFM fans blowing on the tank to regulate that temperature. So we'll take you down below as well, give you a quick peek under the hood. We have this cartridge filter here and two pressure sensors on either side of that filter so that we can monitor via the software when that filter needs to be cleaned out. We're utilizing a pleated stainless steel filter that can be rinsed off and reused. And it's really easy maintenance. You just shut off these ball valves, pull the cartridge out, rinse it off, put it back in every so often, depending on your throughput. You can see that everything is made of either high-grade stainless. We have really robust plumbing, and so everything's easy maintenance, is going to last a long time. In terms of fixturing options, right now we're just running a PolyJet part in here, but we would have a fixture to accommodate your SLA platform, similar to the one I showed you on the 40. So in the same fashion, we're going to drop this in. And if you'll take notice of the software, the TeamViewer application on your screen, I'll be doing a few things in the software to show you what it looks like. So firstly, I'll show you manual mode. On the top left here, we have our pressure output. And so if I turn the pump on, you'll see that the pressure rise. And it's not too high pressure. We're just circulating fluid, encompassing those parts, making sure we get good coverage. Also, that motion is going to help get inside internal cavities, tough geometries that are typically challenging to clean if you're doing it by hand. Or let's say, you have a Tupperware container or a tank with just isopropyl alcohol. This is going to be much more effective for you. If I turn my ultrasonics on, you'll see the output in the top center of that screen, and that's a percentage of the total output power. The top right, we have our temperature currently at 75. It's roughly ambient, great for SLA applications. We can manipulate our ultrasonic level from 0 to 100%. We have our temperature limit set at 100 degrees Fahrenheit. If I were actually running an SLA part, I'd have that down to around 90. And I was mentioning our fans for regulating the temperature. Now, everything I just showed you here I was able to manipulate those components individually in manual mode. But once I go into auto mode, it's much more simplified, and all of those features are accomplished in the background. And so all I have to do in manual mode when I have it set up for resin removal is select my ultrasonic output power in percentage. I have my temperature limited in the background. And then my cycle time, which again, anywhere between 5 and 10 minutes typically. We do have some applications in particular with clip technology, some DLP resins as well, where the cycle time is even more precise, like down to 30 seconds in some cases, or 3 minutes in others. So that cycle time becomes very precise. We want to prevent overexposing that green part, or that that build before it's cured in the UV oven. We want to limit exposure to prevent damage or compromising the material properties. And so with the cycle times in that low range, we're able to do just that. Now, traditional methods, like what I'm used to seeing when I'm replacing traditional methods in the field with a Demi, for example, is either a submersion tank with a dirty batch of isopropyl alcohol or TPM, and then your platform goes in there for say 15 to 20 minutes. You take it out of there, put it into a cleaner batch of IPA or TPM, for example. Do that for anywhere between 5 and 20 minutes, dictated by your process or your workflow. Once you're out of that, you hit it with some air, check for resin to see if there's any leftover resin. A lot of times there is, especially in internal cavities, and so then it goes back into the alcohol, or even worse, you have technicians brushing the part off with like I've seen toothbrushes, paintbrushes, syringes, picks. It really is a dirty manual process. And so we've been able to address that pain point by automating the process, using our hardware, software, and chemistry to do all that work for you. Really, the nice thing about our Escalade detergent, and the reason it works so well, is because we're using a diverse blend of organic solvents versus just a singular solvent like IPA or TPM that we're used to seeing in the field. And by utilizing that blend, we're able to cast a broader net and effectively clean all types of different functional groups within the resin varieties that we've seen. And so we're able to not only clean multiple different types of resin in the same batch of detergent, but I think we've tested up to 8, running 8 simultaneously, but we have dozens of validated resins under our belt, including Escalade, DLP, and Clip. The reason it's so effective, we have a low surface tension in that detergent, so we can get into tight little corners or cavities, through holes, fine lattice structures, better than higher surface tension solvents. And so that really serves, it lends itself well to cleaning difficult geometries and reduces touch time after coming out of the solvent. So I've touched on the chemistry there for a little bit. We're going to go back in and focus a little bit more on the software. I've showed you manual and automated mode so far. One last thing on automated mode that's really helpful is the ability to save and store recipes. And so let's say that I have that key part that I showed you earlier. I think I have the example sitting around here somewhere. Thank you. So I'll use this key for an example. Let's say I have a production run of 10,000 of these keys, for example, and I only have to set up that ideal recipe once. Once I find that correct ultrasonic level, that correct cycle time, I can go ahead and save it as a recipe, name it whatever I want. I'll just name it key for an example. I can save it, and then if I have technicians on different shifts, I don't have to rely on them setting up the right parameters. I can just instruct them to come in here and select that recipe, drop the parts in, hit start, and let the process do its thing. Come back 5-10 minutes later, pull them out, rinse them off, in either water or isopropyl alcohol, and I'll cover that more in a little bit. So our Forte over there just finished up its 10-minute cycle on that key, so we'll go back over there and take a look. Alrighty, let's switch out gloves quickly. All right. Give it a little shake. And so I'm going to have Francesca rinse this off and dry it. But before we do, I just wanted to give you a little close-up view. And I'm dripping all over. But anyway, that's the detergent residue on there. As you can see, that sheen. And I'm going to pass this off so they get rinsed and dried. And the nice thing about our detergent is that you can rinse it off in either water or isopropyl alcohol. Either works. The only advantage to using IPA is that it evaporates off faster, so it'll dry a little bit faster. But if you're hitting your parts with compressed air anyway, or just sitting them out to air dry, water works just fine to rinse them off. You know, it's cheaper. We want to limit the number of solvents you have on hand, and that's what we've been able to do the majority of the time. You know, if you take carbon, for an example, that's just the air in the background there. Carbon, for example, they recommend, depending on the resin that you're utilizing, either IPA, DPM, Bertrell, and so you might have upwards of 3-4 different types of solvents that you're managing in your chemical lab. And now you have the ability to reduce it down to a single chemical, our Escalade detergent, and just utilize water for rinsing. And so you can see, if I pass along the camera there, all the resin's off of there. This is ready to go in the curing oven. Alrighty. Cool. So a few other things about our Escalade detergent. You can distill it. In fact, you can recover up to roughly 60 to 70% of our saturated detergent. The other benefit is that it saturates much more slowly, or a better way to say that is our longevity on that detergent is far greater than your traditional solvents like IPA and TPM. It lasts up to 8 times longer than IPA, for example. And the reason for that is simply the consistency of the cycle time. So in our field validation, for example, we ran just over 1,000 platforms. 96% of those platforms were completed in between 5 to 10 minutes. That other 4% were just extreme geometries that many are probably used to, you know, like really long, tiny channels. And those simply just required a few extra minutes on that tail end. You know, so that 4% might have been in the machine for, let's say, 12 to 15 minutes. And of course, there are the extreme cases that you might have to do a little bit of manual touch-up. But generally speaking, your manual touch time or manual labor in general is going to be drastically reduced when you move to an automated solution with a more effective, more diverse blend of chemicals like our detergent for SLA. So that translates to, you know, not only just the longevity, but also reduced waste. And so if you're having your waste solvent carried off and disposed of as hazardous waste, that cost, or that operating expense, is going to be reduced up to 8 times as well, since you're able to use our detergent much, much longer. Okay, so we're about 20 minutes after the hour. I'm going to open it up for a few questions. And feel free to post those questions in the chat on your go-to, and I'll take them as they come through. Okay, so a question here is, what is the narrowest channel your Escalade detergent can get into for resin removal? That's a great question. So we have not run into a scenario where the channel has been too narrow. I don't have an exact measurement for you, but as I was mentioning earlier, that low surface tension does a great job on finding its way through the tiniest channels, and that in conjunction with our intelligent application of ultrasonics loosens up that resin in those fine channels or fine lattice structures where it's very crowded, and we have the ability to clean those much more effectively than your traditional methods. All right. Another question here is, what is the process to remove the excess resin left over in the machine? Okay, so we're referencing the maintenance operation here, which is pretty simple. It's the maintenance. You're not going to have to do it as often since our longevity is much greater. When you do, though, you have a few options. So throughout the process, over weeks or months, you can take some of the detergent out and replace it with virgin or distilled detergent to keep that consistency level, or just a consistent level of saturation throughout your process. Once the detergent becomes fully saturated, though, and that's roughly 30% resin to detergent ratio, and so our Demi, for example, holds 40 gallons roughly of our detergent. So you're looking at around 13 gallons of resin that can be dissolved in the Demi before you're going to have to drain it out completely, either have it carried away as waste or distill it, and then what's left over with the resin in the machine, you can rinse it out, throw a little fresh solvent in there, or just clean it out with a couple of rags, run the pump with some fresh solvent, and you're good to go. As long as you're maintaining the cleanliness of your filters, changing those out periodically, you should be fine. Maintenance is very easy. There's a question here. Can you put different resin materials in the machine at the same time? Yes, you can. So in our field validation, we were running up to 8 different resins simultaneously. That included clear, black, white, a composite with ceramic material within, and all those resins were able to be run simultaneously up to the point of saturation without any color transfer. The only exception to that is if you're running a really heavy composite ceramic, for example, and then you're saturating that detergent with composite, and you run a black part through there, you might be able to see the white powder, but that can be easily brushed off. Alrighty. What is the chemistry made of? So it is actually our proprietary blend of solvents. The main ingredient actually gives off a pleasant citrus odor, which is much better than your traditional solvents, which are very unfriendly and unpleasant to be in the same room with. So our working environment is much better. All right. Okay, guys. Well, we're going to wrap up there, and I really appreciate you joining us for this live solution experience showcasing our resin removal capabilities. Feel free. We have the screen loading up here to schedule a virtual event where we can get some personalized attention on your particular application to see which solution is going to work best for you and how we can address some of your pain points. We also have a benchmarking service, so if you go online to that link there, you can fill out a benchmark request form, send your parts to us. But if they're SLA parts, it can be difficult to send those parts via the mail, especially if they're still covered with uncured resin. And so we do have some print capabilities here in our lab in Buffalo, New York. And so if you can send us an STL file alternatively, we'll print it in-house, and then you can join us for a virtual solution experience with some one-on-one time in the lab. We'll show you running your part real time and what the end results look like. We can also return those parts to you with what we call a performance evaluation, where we'll outline before and after pictures, processing parameters, and exactly what it took to achieve the results that you're looking for. Once again, thank you everyone for joining us. We look forward to seeing you at one of our other virtual events this week. Feel free to sign up for a coffee chat, another live solution experience. We have them for PolyJet and STM as well. or a virtual solution experience tour, webinars, you name it. We'll look forward to seeing you there. Have a good one. Thank you.